Now that we've covered the right triangle definitions of the trigonometric functions, let's take a look at some facts that we can observe from the definitions themselves. We're going to call this set of facts the fundamental identities. First of all, you can notice simply by observation of the definition that sine and cosecant are reciprocal values, and cosine and secant are also a reciprocal pair. And then lastly, tangent and cotangent are reciprocal values. And you see these identities evidenced in line 1, and they're referred to as the reciprocal identities. The tangent-cotangent identities are also birthed from the definition. You may notice that if you, actually let me do it this way, if you take the definition for sine and the definition for cosine and fill those in as a quotient, so that would be opposite over hypotenuse divided by adjacent over hypotenuse, your algebra skills would lead you to concluding that this is the same ratio as opposite over adjacent, which is the definition of tangent of theta. Okay, so that is how we get, I'll circle this line. Okay, and then in a similar manner you can produce cotangent, or you can observe that cotangent and tangent are reciprocals, and you pick this guy up as an extra identity, that cotangent is the cosine value divided by the sine value. Now the Pythagorean identities I'm going to spend a little more time on developing. I want you to notice from the right triangle above that you have sides adjacent theta, opposite theta, and then the hypotenuse opposite the right angle. So the Pythagorean theorem, stated in these terms, would be adjacent squared plus opposite squared equals hypotenuse squared. Now you can see in my summary that there are 3 Pythagorean identities that I want to derive. So let's just play with this a little bit. Let's divide both sides of this equation by the square of the hypotenuse, okay, which makes your right hand side equal 1. But you would have adjacent squared over hypotenuse squared plus opposite squared divided by hypotenuse squared equals the value 1. And I did that on purpose, so we're going to actually take turns making somebody in the equation 1. Algebra suggests to us that if you have a square over a square, you can write that as a fraction squared. So I would have adjacent over hypotenuse quantity squared plus opposite over hypotenuse quantity squared equals 1. And then I can go back to my trig definition. Let's scroll back up. These guys, okay, at the top. And I can notice that adjacent over hypotenuse is the definition for cosine. Opposite over hypotenuse in the right triangle world is the definition for sine. And I can substitute those in. This is cosine of theta. This is sine of theta. So the square of the cosine value plus the square of the sine value should give us 1. Now, many times we create new notation to shortcut how we write things. It is acceptable to write the square of a function with the square following the function's name. And WebAssign may also give you some additional information about how to enter things such as this. However, the previous statement is perfectly acceptable as well, because it truly is the square of the entire cosine quantity plus the square of the entire sine quantity equals 1. Okay, so that's our first Pythagorean identity. Now let's take what we did here in this key Pythagorean equation, okay, and repeat it. All right, so if you will take the time to divide by, let's just say, opposite squared, okay, then that Pythagorean relationship becomes adjacent squared over opposite squared plus opposite squared over opposite squared equals hypotenuse squared over opposite squared. And I think you can probably see where I'm going with this. This would be the fraction adjacent over opposite quantity squared plus the value 1 equals the quotient hypotenuse divided by opposite quantity squared using our rules of exponents. And then, of course, adjacent over opposite is the actual definition of cotangent of theta plus 1 equals hypotenuse over opposite, and that is the definition of cosecant of theta, and they're quantity squared here, which again we can write in a shorthand manner that looks like this: cotangent of theta squared plus 1 is cosecant of theta squared. Okay, so we get our second identity. All right, now I want you to try the last one on your own. I want you to start over and divide both sides of our original Pythagorean identity. And last time we divided by opposite squared, so let's divide by adjacent squared. And what you're going to produce, and I want you to do this on your own, work through it, is 1 plus the square of the tangent of theta equals the square of secant of theta, following similar steps as we had above, which can be written as 1 plus tan squared of theta equals secant squared of theta. Okay? All right, so again, in short, we have 8 fundamental identities. Let's go back and look at them one more time. Okay, so we have the 3 reciprocal guys, 2 quotient guys, and the 3 Pythagorean guys. And this will build a basis of identities that we can use to solve problems involving trig functions.